Imagine scheduling a jog for Monday morning in your calendar application. You wake up and start getting ready, but receive an urgent request to attend a meeting at work, so you cancel the jog. That evening, you reschedule it for later in the week. Using an array for this would be problematic. Can you think why? Predicting the number of events a user might have each day is impractical because life doesn't always go according to plan. You need a dynamic solution that can adjust for changes, like those in your calendar. Remember those Java collections you learned already? An array list is exactly what you can use here. Array lists don't require you to set a size up front. You can add events as your day fills up and remove them as your plans change. This ability to grow or shrink dynamically makes array lists perfect for a calendar application or any situation where your data varies consistently. In this video, you will learn about array lists and how to declare and initialize them. An array list is a resizable array implementation within the Java Collections framework, part of the java.util package. It allows you to store elements sequentially, but provides the flexibility to adjust their size as you add or remove elements dynamically. This feature makes array lists useful in scenarios where the number of data elements is unpredictable or subject to frequent change. Array lists also offer built-in methods for adding, removing, and searching for elements, which is an easier and more user-friendly option than traditional arrays. So how do you declare an array list? First, you need to import the ArrayList class from the java.util package. Then you declare an array list specifying the type of elements it will hold. An array list can have elements of a generic type. This type is indicated within angle brackets. For instance, the ArrayList string is an array list that holds strings, while an ArrayList integer contains integers. Array lists can only hold objects, not primitive data types. For these cases, you cannot use primitive types like int, char, and others. Instead, you must use wrapper classes, such as integer, character, and boolean. Now let's explore how to initialize an array list. Depending on your requirements, there are several ways to initialize an array list. It's straightforward. Use the new keyword to create a different instance of an array list. Let's explore some of these techniques. Default initialization is one of the most common and straightforward options. Create a new empty array list with the default initial capacity to do this. You can also specify an initial capacity if you estimate how many elements you need. This can improve performance by resizing frequency as elements are added. However, this does not limit the array list's ability to grow or shrink as needed. You can even create a new array list directly from an existing collection of elements. This is particularly useful when you need to create a copy of a list, perhaps to manipulate it without affecting the original collection. Let's explore how to add elements now that you know how to declare and initialize an array list. Adding elements to an array list is a simple process because of the availability of overloaded methods. Let's use two methods to add elements. Using the addObject method, an element can be added to the end of the list without specifying an index. If you want to insert an element at a specific index, simply pass the object along with the index. It's important to note that array lists come with various built-in methods that make it easy to manage everyday tasks. Functions like size, isEmpty, get, set, and contains simplify common operations requiring manual implementation with traditional arrays, making your code more efficient and less error-prone. You'll explore these methods in detail later in this course. Inserting or removing elements from the middle of an array list can be slow because elements must be shifted to maintain order. For instance, imagine your day is scheduled with 5 events in an array list: morning meeting, email correspondence, study session, project work, and evening jog. Each event is stored in the order you plan to complete them. Now, imagine adding lunch with a client after email correspondence at index 2. The array list must shift study session, project work, and evening jog one position to the right to accommodate the new event. Your updated list will now show morning meeting, email correspondence, lunch with a client, study session, project work, and evening jog. In summary, ArrayLists offer a dynamic and flexible alternative to arrays, making them effective solutions for applications where the number of data elements can change over time. Their dynamic resizing and ease of adding or removing elements offers significant advantages in many real-world programming scenarios, such as calendar applications that must account for frequent updates. How will you leverage the flexibility of ArrayLists in your next project? The choice is yours and the potential is limitless.